Hello everyone, this is the lecture number 17 of the lecture series of Naval Architecture made for MEO examination. In this lecture, we will continue with the numericals on the Simpsons Rule. So in this numerical, we are going to see the application of the Simpsons Rule on the bulkhead. So what we are going to do here, if you remember, in the earlier classes, we have done the calculation of finding the area of the bulkhead, calculation of center of pressure, and the calculation of the load acting on the bulkhead. But in that type of a numerical, we have done this calculation only for the regular shape of bodies like a rectangle or a triangle. The bulkhead was a rectangle or a triangle. But in actual case, bulkhead won't be a rectangle or it won't be exactly a triangle. So for that purpose, we need to use the Simpsons rule. Why I am saying? Because in actual case, the bulkhead won't be like a rectangle or the triangle. It may be like this. It may be a bulkhead look like this. So if you have a bulkhead like this, which is a irregular shaped body, we don't have any exact formulas for this to calculate the area, center of pressure and the load acting on the bulkhead. So for that purpose, we need to use the Simpsons rule. So how to proceed for this? So this is the one of the bulkhead, and you can see this is the center line of the ship, and the horizontal lines you can see, that is the width of the bulkhead from the top of the bulkhead to the bottom of the bulkhead. So that width we are calling as a y0, y1, y2, y3, y4, y5 and y6. So these width will be given to us, and the spacing between this width is given to us, that is h. Now you can see here we have to calculate the total area of the bulkhead and the location of the center of pressure from the top of the bulkhead and the load acting on the bulkhead. These are the three things you have to find out. So for that purpose, what I am going to do now, I will take the top of the bulkhead is a reference. Top of the bulkhead is a reference. So I am going to take the first moment from the top of the bulkhead, second moment from the top of the bulkhead. It means that the reference is the top of the bulkhead, so the location of the center of pressure will come from the top of the bulkhead only. This is the first thing. The second thing is, now the direction of the ordinates and the direction of the perpendicular distance, when you are going to take the first movement and the second movement, both are perpendicular to each other. For example, if you want to take the movement from the top of the bulkhead to the ordinate 5, so this is the perpendicular distance for the ordinate 5. So ordinate 5 is along this direction, and the perpendicular distance is really perpendicular here from the top of the bulkhead. So this is the case like the finding the first movement and the second movement about the transverse axis. So what we are going to do here, whatever the things we have done for finding the first movement and the second movement about the transverse axis, same method we are going to use here. I am repeating once again. In this numerical, the direction of the ordinates, this y0, y1, y2, y3, y4, y5, y6, the direction of the ordinates and the direction of the perpendicular distance, both are really perpendicular to each other. Both are not in the same direction as it was there in the center line condition which we have done earlier. That's the reason we are going to solve this numerical like we have done for the transverse axis method. we have to take the moment about the transverse axis. So the top of the edge of the bulkhead, that is a transverse axis, and these all are ordinates. Now it is decided that this numerical you can solve with the help of a transverse axis method, which we have done earlier. So you have to take the moment about the top of the bulkhead. Okay, so the y0 is the top of the bulkhead. As you go down towards the keel, the width of the bulkhead is y1, y2, y3, y4, y5, y6. Okay, now consider that the width I have written like this. So first column is a width column. So you can see how many width I have taken here. I have taken 7 widths, and that width in general we will call as the ordinates only. So we have a 7 ordinates. If you know the 7 ordinates is there, interval will be 6. So 6 is divisible by 2 as well as a 3. So you can use any of the rule. You can use Simpson's first rule or the second rule for the calculation. I am using here Simpson's first rule. So this is the Simpson's multiplier here, 1, 4, 2, 4, 2, 4, 1. As they have not mentioned anything about the spacing between the ordinates, and we can write the Simpson's multiplier accordingly. So now you can say the width is column number 1, Simpson's multiplier is column number 2. Product for the area we were calling till now about a function of area. So column number 3 is a function of area. Column number 4 is a lever. Column number 5 is the function of first moment. Column number 6, once again we have taken the lever here. Column number 7 is the function of a second moment. Okay, so column number 3, that is a function of area, you will get by multiplying the column number 1 and the column number 2, then you will get the column number 3. So this is the summation of function of area. Then the lever, for taking the lever I am taking the top of the edge as a reference. So from there the lever will be 0, 1, 2, 3, 4, 5, 6. There is no half spacing, so it will be continuous number from the 0 to 6. Then function of first moment, how to calculate that? You have to calculate by column number 5 is column number 3 multiplied by column number 4, you will get the column number 5. Then you can get summation of function of first moment. Then again function of a second moment, that will be 2 times we are taking the moment. Column number 7 is equal to column number 5 multiplied by column number 6. Then you will get column number 7. At the end, do the algebraic summation, you will get a summation of a function of a second moment. These all the calculation we have done the earlier also. So I am not discussing in detail about this whole tabular thing. The main thing which I am going to discuss about the first moment, the load acting on the bulkhead, and the location of the center of pressure. So like this, from the table you got the function, summation of function of area, summation of function of first moment, summation of function of a second moment. Now how to calculate the area of the bulkhead? Again, the area of the bulkhead is equal to h by 3. Why it is h by 3? Because it is Simpson's first rule. So it is h by 3 summation of a function of area. Summation of function of area. Here they have written summation of A only. Both are set. Then first moment, for the calculation of the first moment of area, if you remember, we have seen this formula. H by 3 is Simpson's rule. Then we are taking first time movement, that's the result, there will be one h is a common, then multiply by summation of function of first movement, which we got from here. The same thing you have to substitute, then you will get this h square by 3 into summation of first movement. Then now we know that the load acting on the bulkhead, the formula was like this: rho g a h. This formula already we have seen. Now what is ah? What is ah? Ah is the first moment of the area. In earlier numerical, the it was a regular shaped body, so we can directly written ah. But this is not a regular shaped body; it is an irregular shaped body. So this, instead of ah, we can write directly the first moment of the area. So the load acting on the bulkhead will be rho g into h square by 3 into summation of first moment summation of the first moment. Like this you can calculate the load acting on the bulkhead. The third point, that is a location of the center of pressure. Center of pressure is equal to the moment of inertia of the whole bulkhead about the free surface divided by AH. Again you try to understand this. I00, that is a moment of inertia, also called as the second moment of area about the free surface. In this case we have taken the free surface is at top of the bulkhead divided by the first moment of area. The same thing we have written over here. Then you will get the location of the center of pressure like this: H into summation of function of a second moment divided by summation of a first moment. Like this you can calculate the location of the center of pressure. So let's start the discussion on the numerical to understand the concept which we have discussed just now. A 4-peak bulkhead is 4.8 meter deep. So I have drawn here one of the diagram of the bulkhead, and it is a depth of this bulkhead is a 4.8 meter and 5.5 meter wide at the deck. So this is the 5.5 meter. At the regular intervals of 1.2 meter below the deck. So intervals means they are talking about the spacing between the ordinates, consecutive ordinates. So we can write h is equal to 1.2 meter. The horizontal widths are, so they have given all the width. So the width at the deck, that is a 5.5 meter, then 5 meter, after that we have 4 meter width, then we have a 2.5 meter width, and finally it is a 0.5 meter width. The bulkhead is flooded to the top edge with the sea water on one side only, means water is there up to the top of the bulkhead. Calculate the area of the bulkhead, the load acting on the bulkhead, and then the position of the center of pressure. Now how to proceed for this numerical? As we have seen, this is not a regular shaped body, so you cannot solve this numerical with the help of just a formula which was available earlier. So we have to use the Simpsons rule here. So before starting the Simpsons rule, what are the things you have to see? You have to see how many ordinates are there. There are 5 ordinates. It means that 4 number of intervals are there. So 4 is completely divisible by 2. So we can use the Simpson first rule. To solve this numerical, we need to create a table. So first column is a depth. The second column is the width. Third column is a Simpson's multiplier. Column number 4 is the product for the area. Generally we used to call as a function of area, that is equal to column number 2 multiplied by column number 3. The column number 5 is a lever. We are taking the reference as a top of the bulkhead. The column number 6 is column number 5 multiplied by column number 4. Column number 8 is column number 6 multiplied by column number 7. Okay, so depth is starting, the top of the bulkhead is a 4.8. The interval between the two consecutive ordinate is 1.2. So the top of the bulkhead is 4.8, then 3.6, 2.4, 1.2 and 0. You can see this is the depth is divided in a equal spacing. Then the corresponding width is given 5.554 2.5.5. Simpsons multiplier is 14241 as it is a full spacing and we are using the first rule of a Simpsons, so it will be 14241. Product of area, the top of the bulkhead as a reference, so we will start the lever from the top of the bulkhead. It will be top of the bulkhead will be 0, then 1 2 3 4. Then find out the function of a first movement, find out the function of a second movement, do the summation. You will get this value, that is, you can say the function of area, this is the function of first movement, and this is the function of a second movement. So common interval is 1.2, that is h. Area of the bulkhead will be again the same formula, h by 3 into summation of function of area. Load acting on the bulkhead, that is rho g into h square by 3 into summation of function of first movement, and the center of pressure will be summation of second movement into h divided by summation of a function of first movement. So like this you can calculate the location of the center of pressure. So this 2.647 is measured from the free surface. It is measured from the free surface from here. So this is the location of the center of pressure. Let's see one more numerical to understand the concept of numerical integration. So in this numerical, a ship 140 meter long and 18 meter beam. So this 18 meter beam which is given, that is the maximum beam of the ship, floats at the draft of a 9 meter. This is the maximum draft of the ship. The immersed cross-sectional areas at equal interval are given like this: 5, 60, 116, 145 and so on. Calculate the displacement, block coefficient, midship sectional area coefficient, prismatic coefficient. Let's draw the diagram of the ship showing the cross-sectional areas. So you can see there are multiple cross-sectional areas shown here. So hatching part which I have shown, that is the cross-sectional area. Like this you have around 11 cross-sectional areas. So in this numerical, this cross-sectional areas itself called as a ordinate. The cross-sectional areas itself called as a ordinate, and the spacing between the each ordinate or the consecutive ordinate we need to find out. So if you have a ordinate is 11, so how many number of intervals will be there? It will be a 10 number of intervals are there. So total length of the ship is 140 divided by number of full spacing ordinates, that is 10. So it will be h is equal to 14 meter. The spacing between the consecutive ordinate is 14 meter. So this thing you have to keep in your mind. Now which rule is applicable here? So we have a 10 number of intervals. It is divisible by 2. So you can use the Simpsons first rule. It is divisible by 2. So we can use the Simpsons first rule. So you can see here the cross-sectional area is written in the vertical direction. I am calling as a column number 1. So as we have decided to use the Simpsons first rule, and there is no half spacing, half interval is not there, so everything is a full spacing. So Simpsons multiplier will be starting from 1 ending with 1, 1, 4, 2, 4, like this you have to write. Then that is a column number 2. The column number 3, now the ordinate is given area, the unit is meter square. So column number 3 will be function of a volume, that is a function of a volume. So column number 3 will be column number 1 multiplied by column number 2. So if you do this calculation, you will get a summation of a function of a volume. You will get the summation of the function of a volume. We have done already the calculation for the common interval h is equal to 14 meter. So first sub question was calculate the volume of displacement. So how to proceed for that? The formula for that, h by 3, this is the Simpsons rule, h by 3 multiply by summation of a function volume which we got from the column number 3. That we have to substitute here. H already we have done the calculation. H is a 14 divided by 3 into function of a volume. You will get a volume of a displacement. But if you want to calculate the displacement, this formula rho is equal to mass upon volume. You need a mass, that will be mass is equal to rho into V. So density you have to take as a seawater density multiply by the volume which we got here. You will get the answer in a tons, that is a displacement. After that we have to find a block coefficient. What is the formula for the block coefficient? CB is equal to the actual volume of a displacement divided by L into maximum beam into maximum draft. This all the thing is given to us. You substitute here, you will get the block coefficient. Now the third question was a midship section area coefficient. The formula for this. The third question is a midship section area coefficient. The formula for this, CM is equal to actual area, that is AM, divided by beam into a draft. Now what is the AM here? From the table you will find which is the midship section. The corresponding AM you have to take, that is 153 divided by beam into draft. You will get the midship section area coefficient. The fourth question or the sub question is prismatic coefficient. That is the volume of a displacement divided by the length of the ship and the midship area, actual midship area, that is AM, which is given 153 into length, that is 140 into 153. Actual volume we have already calculated here. Substitute here, you will get the prismatic coefficient. Let's do one more numerical. Now in this numerical you will find the water plane area is given. If you compare in the earlier numerical, in that numerical they have given the cross-sectional areas and they have asked to find out the volume of displacement of the ship, and the corresponding sub questions was there. In this numerical they have given the water plane area, which I have drawn here. You can see these all are a water plane area. In this diagram I have drawn only two water plane area. There may be in this diagram you will find there are two water plane areas I have shown, but there might be chances that you may have more number of water plane areas. So in this numerical they have given some water plane area. Let's look the question. The water plane area of the ship at a 1.5 meter intervals. It means that they are saying there are a water plane area and the gap or the spacing between the each consecutive water plane area is 1.5 meter. So that is H. Of the draft commencing at the keel R. So these all are water plane areas are given. So here there are 7 water plane areas are there. It means that, so here you can see the number of ordinates are 7. So number of intervals will be 7 minus 1, that is a 6. Again 6 is a completely divisible by 2 as well as it is completely divisible by 3. You can use any of the rule for the calculation of the volume of a displacement. So I am going to use the first rule here. Let's start the discussion on this numerical. So whatever the water plane areas they have given, that I have written in the column. So I will call as a column number 1. Simpsons multiplier is a column number 2, and column number 3, that is a function of a volume. Why it is a function of volume? Because ordinates are the areas. So column number 3 will be column number 1 multiplied by column number 2. You will get a summation of a function of volume here. So if you know the summation of function of volume, you can calculate the volume of displacement is h by 3 summation of a function of a volume. So you will get the actual volume here. Then multiply with the density, you will get the displacement, that will be in tons. So in this case, the summation of function of volume is coming 34890. Interval is already given, that is 1.5 meter. Substitute here, you will get the displacement in tons, that is 17881. Let's do one more numerical on the Simpsons rule. The numerical is like this: the TPC values of the ship at 1.5 meter intervals of the draft commencing at the keel are, these are the values are given. Calculate at the draft of 9 meter the displacement of the ship and the kb of the ship. So what is the meaning of a TPC? TPC means tons per centimeter. So we know the formula of a TPC. It is rho into water plane area by 100. If they have given a TPC, it means that indirectly they have given the water plane area only. Try to understand, in earlier numerical, they have given the water plane area, we have Simpsonized the water plane area, and you got the volume of a displacement, it was in a meter cube. But in this case, they have given the TPC as an ordinate. It means that they have already given rho is multiplied with the AW. It's like that only. So if you Simpsonize the TPC, at the end you will get directly displacement. No need to multiply with a rho at the end of the answer, because that rho is already considered here in a TPC. The second sub question which is asked is finding the KB. Now what is the meaning of KB? KB is a distance between the keel to the center of buoyancy. So B is the center of buoyancy, K is the keel. Okay, so this distance we have to calculate. It means that you have to find out the centroid of the underwater volume. You have to find out the centroid of the underwater volume, and that you have to measure from the keel, that is called as a KB. Let's create again the table to do the calculation. So first column is a TPC which is given to us, and that is a TPC is now ordinates. So please check once again how many ordinates are there. 1, 2, 3, 4, 5, 6, 7. There are 7 ordinates. The number of intervals is a 6. The 6 is divisible by 2 as well as a 3. You can use any of the rule from the Simpsons. I am using the Simpsons first rule. So the Simpsons multiplier will be the second column, that will be 1424241. The product of first product for the displacement is, now this is the column number 3, is a function of a displacement. Now why I am saying function of displacement? Because the ordinate is a TPC. If the ordinate is a volume, then this will be a ordinate is an area, then this will be a function of a volume. Now in this case, it is a ordinate is a TPC, so this will be function of a displacement. So column number 3 you can calculate by column number 1 multiplied by column number 2. Then the column number 4 is a lever. Column number 4 is a lever starting from 0, 1, 2, 3, 4, 5, 6. Now you can see here this lever, the TPC which we have taken here 4, that is at the keel, that is at the keel. So the 0 which we have taken, the keel is as a reference. We have not taken the top of the ship is a reference. We have taken the keel as a reference. So we are measuring the lever from the keel and it is increasing along the depth. So 0, 1, 2, 3, 4, 5, 6 like this. The column number 5 is your product of a first movement, that is column number 3 multiplied by column number 4, you will get the product for the first movement. The important thing here, whenever you will have ordinate in a TPC, the interval you have to take always in a centimeter. The interval here it is given h is equal to 1.5 meter, but always keep in your mind whenever you have a TPC as ordinate, you have to convert this interval in a centimeter, so it will be 150 centimeter. Then the sub question A is finding the displacement. So formula for that, h by 3 into summation of function of a displacement. H should be in a centimeter. Then you will get this displacement directly in a tons. The sub question B was finding the value of a KB. What is a KB? KB is the centroid of the underwater volume. The formula will be remain same, which we have already seen for the calculation of the centroid. That will be H into summation of a function of a first movement divided by summation of a function of a displacement. So like this you can calculate the value of a KB. I hope everything is clear to everyone. If you are visiting my channel first time, please like, share and subscribe. Thank you very much.